I say, you're not supposed to.
What about the PSAT?
I was going to say, you are supposed to stay for the rest of the day.
Calling my mom. My mom will be taking the day off so I can move on.
All right. This is still 4.1. So what we're going to do here is we're going to chill so I don't have to yell. We're going to be using that intermediate value theorem, what we did yesterday, to show that there has to be a root between 1/2 and 3/4. So we're going to find f of a and f of b. So we need to show that f of a has some certain value, and we're going to find f of b with that value, because that's what we can use for that theorem. So f of a, they've told us our a is 1/2. So this is really looking for f of 1/2. So we're going to substitute that into the equation. So we're going to have our 2 times our 1/2 to the 4th plus 3 times 1/2 minus 2. And aren't we so happy that we can use calculators for this now? 1/2 to the 4th. I mean, you can do that. 1/2 to the 4th. We know 2 to the 4th. That's 16. So 1/2 to the 4th would be 1/16. Times 2 would give us 1/8. Plus 3/2 minus 2. So what are we going to get when we simplify our f of 1/2? What is the value of f of 1/2?
Negative 6/16. Is that correct? It's probably not.
Yeah, it's just not simplified.
So that would be negative 3/8.
Mm-hmm. Same vibe for our f of b. So we're going to find our f of 3/4. So we're going to have our 2 times 3/4 to the 4th plus 3 times 3/4 minus 2.
For 1/2 to the 4th,
Mm-hmm.
how did you do that?
So you can do it as 2 to the 4th. 2 to the 4th is 16. 2 times 2 times 2 times 2. So 1/16 times 2. That's where we got the 1/8 from. I took this piece in here. Or we can do, and I'll show it here. Hang on, let me get the calculator pulled up. You can also, in the yellow calculator, go 2 times 1/2 to the 4th. And you can just type it in like this, and it'll spit out your 1/8. Plus 3/2 minus 2. And it'll even simplify it for you. So when we do it for the second one, where we have our 3/4, we can do our 2 times 3/4 to the 4th. And just start typing it in the calculator like this. Plus 3 times 3/4. Oops. Get that out of the fraction. Poop. Minus 2. Type it in the calculator. Boop. My favorite button on these calculators is this one right here. N over D, second column, third button down. That is the one that makes our fractions look like a fraction. This is the same as the yellow calculators. It's the exact same buttons in the exact same spots, exact same order. This button right here, I know it's really hard to see my laser pointer. Second column, third button down. That one, it's now lit up red. That button is my favorite button. It makes our fractions look like fractions. But we wound up with 113 over 128 here. So 113 over 128 was our f of 3/4. So are we going to have a root between these two values?
Yeah.
Why? Because I have a negative value here and a positive value here. So somewhere in between there has to be a 0. So the way we say this to show that we have a 0 here is since f of A is less than 0 and our f of B is greater than 0, there must be a root between A and B. So that's what our intermediate value theorem was telling us.
Is it okay to say there must be a 0 between?
Yeah. 0, root, solution, intercept, those things all mean the same thing. Okay. Questions on this one? Okay. So, mind the bad typing because I was changing our instructions to where it's matching what's in the homework. So, our equation here is going to be f of x equals x cubed minus 3x squared minus 10x. And what we're asked to do is to find all values of x where f of x is greater than 0, where f of x is less than 0, and we're going to make a sketch. So we're going to use all those things we found yesterday. We're going to use our degree and our leading coefficient to find our end behavior. We're going to see if we can try and find some roots. We're going to find some zeros, and we're going to probably have to do a positivity table in order to find where it is greater than or less than 0. So, okay. So first things first, what I'm going to ask you is, what is our degree? 3. What is our leading coefficient? So we can use that to find our end behavior because are we even or odd? Odd. And are we positive or negative? Positive. So what's our end behavior going to be? F of x approaches negative infinity. And as x approaches positive infinity, what's happening to our f of x? Positive infinity. Because our odd functions have that same end behavior as the line, and a line with a positive slope has these arrows. So for our sketch, because we're asked to do that too, I'm going to just put a little thing over here. If you want proper graphs, I did put them out on my little table at the front. You're welcome to do that. I'm just going to do them sketchy style. So I know that my left arrow is going to point down, and my right arrow is going to point up. That's what we know from our end behavior. My left arrow points down, my right arrow points up. What is my y-intercept going to be? Our y-intercept is going to happen at 0. It is our constant added on the end. It's what happens when x is 0. So you could also substitute in 0 for x. So we're going to have an intercept at 0, 0. What's up? That's one of our roots then. Because that's the next thing we need to find so we can do our sketch here is we need to see if we can figure out where the heck our roots are. So the way we're going to do that is we're going to look at our function, our f of x. I'm just bringing it down here so I can work with it. My x cubed minus 3x squared minus 10x. And what could I do if I wanted to find the roots here? Factor. I've got a GCF here of what? X. So that's going to leave me with x squared minus 3x minus 10. Can we factor this into what? Yeah, our pair of numbers that multiplies to make negative 10 and adds to make negative 3. That's our negative 5 and positive 2. So our factored form here is going to be x minus 5 and x plus 2. So our roots, coming back up to this spot right here, are going to be where? 5, negative 2, and 0. Mm-hmm. So we're going to have a root at negative 2, and we're going to have a root at positive 5. And since we're just doing a sketch over here, we could probably connect those together. But since we're also looking for where f of x is greater than and less than 0, I'm going to go ahead and do our positivity table so that we can see that part too. We've done these before, but it's been a little bit, and I'm going to give myself a little bit more space. I promise I will zoom it back in. So when we're thinking about our positivity table, that's when we're going to do the, like the number line where I put my roots in order. So we have our negative 2, 0, 5. And I take all my factors, my x minus 5, and my x plus 2. It's been a minute, but we've done these. And our f of x. This is to figure out where it's above 0, so where is it positive, and where is it below 0, where is it negative. So these are the exact instructions that are in the textbook, is to find where f of x is greater than 0, f of x is less than 0, and a sketch. So the positivity table is how we see where it is above and below 0. So we take our roots down here, trying to make it so it's not super tiny. And we're going to see what happens in each of these intervals outside of our roots, because we know it's going to hit 0 at those intervals. So if I have a number that is smaller than negative 2, what's going to happen with x? Is it going to be positive or negative? And this one is going to be negative. I'm going to go in rows. Over here, is this going to be positive or negative? Negative. How about this one? Positive. And positive. So we're looking at if we're in between these two values, so between 0 and 5. So maybe my x is 2. Since this is just x, it just is positive. We're evaluating our positivity table here. So if I have an x that is smaller than negative 2, down on this side, and I have it here, negative, maybe it's negative 3 minus 5. Is this interval going to be positive or negative? Negative. Is this interval between 0 and negative 2 going to be positive or negative? Negative. Is this interval going to be positive or negative? Negative. Is this interval going to be positive or negative? Positive. How about for x plus 2? Is this going to be positive or negative? Ooh, careful. Negative. Think about if it was negative 3. Negative 3 plus 2 is definitely negative. That's still negative 1. What if we're between -2 and 0? Positive. Between 0 and 5? Positive. And between 5 and infinity? Positive. So it's been a minute, but we've done these before. Questions on the filling in of the table. So now we have our bottom row left to go, where we take and we multiply these together. A negative times a negative times a negative is going to be negative. A negative times a negative times a positive, positive. Sorry, that was meant to be pink. Positive, negative, positive. Positive, positive, positive. Positive. So I know that left of -2, we are negative. Whoa. Let's try that with a sane size marker. There we go. Between -2 and 0, it is positive, so it's above my x-axis. Between 0 and 5, it is below my x-axis. Between 5 and the arrow, it's positive. It's above my x-axis. So that's what our positivity table tells us. So our intervals, looking for where it's positive and negative, f of x is greater than 0 between -2 and 0 and 5 to infinity. These are the places where it's greater than 0. The places where it's less than 0, f of x is less than 0, is going to be our -infinity to 2. I'm sorry, -2. And from 0 to 5. So for the questions on the homework that are between 15 and 30, so 15, 19, 21, 27, this is what you do for them. Didn't sound like a ringtone. Okay, we're going to practice this again. Okay.
I have a question on the last one where you put when f of x is less than 0.
Uh-huh.
The last parenthesis, why is 0 5?
Because it is also negative on this interval between 0 and 5. It's negative from -2 to infinity. It's below my x-axis here. That's what we're looking at. It's where it's above versus below my x-axis. There we go. So this guy, these guys, these guys. These guys are all related. I'm just trying to color code it so we can see it. Okay? All right. Let's do another one. Sometimes we'll get it in factored form. So we're going to do the same process. So we have r of x equals x squared times x plus 2 times x minus 1 squared times x minus 2. So first thing, what is our degree? It's not 2. 6. Because I have x times x, so there's 2, 3, 4, 5, because it's been squared, 6. 6 x's, so our degree is 6. What is our leading coefficient? 1. So what is our end behavior? Why positive though? Because it's an even positive, so both arrows are going to point up. So as x approaches negative infinity, r of x approaches positive infinity. And as x approaches positive infinity, r of x approaches positive infinity. Both arrows point up because it's an even function. Our degree tells us it's even. Where are we going to have roots? So negative 2, positive 1, positive 2, and 0. Don't forget about these guys. Got that x squared out front. So since we're looking to figure out where it's positive or negative anyway, we're still going to make our positivity table. And I'm going to put my sketch over here. Boop. So I'm going to put my roots in order. So I'm going to go negative 2, and then 0, and then 1, and then 2. And we're going to just take all our factors from up there. We've got our x squared, which I'm going to just leave that as x squared. You could separate out and do x and x, but I'm going to put it as x squared. We're going to have our x plus 2. Again, I'm going to take my x minus 1 squared and my x minus 2. And then we'll have r of x. Oof. I did not give myself very much space down there. There we go. So there's a couple rows in here that are going to be really easy to fill in. Because if we look at x squared, is that going to be positive or negative? Positive for everything. Because x squared does not come negative. No matter what's inside, no matter what x is, it's always going to be positive. So what other row can I fill in with all pluses? The x minus 1 squared is always going to be positive. So we really only have to think about 2 rows. So with my x plus 2, if I have a number that is smaller than negative 2, is this going to be positive or negative? Negative. Because if we had something like negative 3 plus 2 would be negative 1. What about if we were between negative 2 and 0? Positive. How about between 0 and 1? Between 1 and 2. And bigger than 2? Positive. So how about with x minus 2? We're going to start with a negative. How about if we're between negative 2 and 0? Negative. Between 0 and 1? Negative. Between 1 and 2? Negative. And bigger than 2? Positive. So our function as a whole, positive times a negative times a positive times a negative, is positive. Positive times positive times positive times negative. Positive times positive times positive times negative. Positive times positive times positive times negative. And positive. Boop. So when we're looking at our intervals where where r of x is greater than 0, where do we have? From negative infinity to negative 2, and from 2 to infinity. And if we're looking for our r of x that is less than 0, what are we going to have? Yep, separate intervals. So -2 to 0 and 0 to 1, union 1 to 2.
And you could do a -2 to 2.
Because it specifically says less than 0, not less than or equal to, we have to skip over the roots. We have to skip over those zeros. So when we're doing our sketch, I know that both of my arrows point up. I know I have roots at -2 and 0 and 1 and 2. I know it's going to be above the x-axis, left of -2, and right of +2. And in between, it's got to stay below. So it's going to come down here and bounce off, and then connect. And we don't know for sure how deep they go. They might not be shaped like that. They might be like super wonky and like little, and then maybe like really big. Or it could be really little, medium, large. We don't know how deep those little loops go. So there's choice in there. We do not have the information to get further than that. We would need to have like a t-table for that. Okay. Questions on this one? We're going to do one more like this because one of the ones on the homework is kind of obnoxious. So we're going to do one very, very much like 15. And we're going to do the same thing here, but the instructions just say sketch here. But so we have our -1/9 x cubed minus 3. So first things first, what's my degree? 3. What is my leading coefficient? -1/9. So what is our end behavior? As x approaches -infinity, what happens to f of x? F of x approaches +infinity because we are an odd function this time. So we're going to have alternate arrows. What about as x approaches +infinity? F of x will approach -infinity. So let's see if we can figure out where we've got some roots maybe. So our f of x is our -1/9 x cubed minus 3, which is super gross, right? I'd really rather deal with that x cubed if it didn't have a number in front. Because we can deal with cubes. We've done that before. But not when they have like fractions and gross things, right? So what I'm going to do is I'm actually going to factor that -1/9 out to make this be something significantly more palatable. So I'm going to make this -1/9 come out as a factor. So I'm going to divide that out of both terms. It's going to leave me with an x cubed in here. And if I have -3 and I divide it by -1/9, what are we going to have?
1/3.
3/1 divided by 1 over 9, keep the 3 over 1, flip the 1 over 9, 27.
Do we keep the minus sign? Yeah, and that's a negative. Or we're taking that out?
We're taking the negative 1/9 out. So we're going to have a positive 27. The fraction, pulling out the fraction makes it get bigger because we're dividing it by a fraction. If I redistribute that 1/9 through, we would wind up back where we were. So when in doubt, if you're not sure if you did it right, if I distribute 1/9 into there, we'd wind up with our negative 1/9 x cubed plus negative 27 over 9, which would be negative 3. So can we factor this now?
Yeah.
Using what? Soap. So what's it going to be?
X minus
Whoop. X what?
x plus 3
Uh-huh.
and
X squared minus
3x
3x
plus 9.
plus 9. We still have our minus 1/9 up front. All right, so we can find one root for sure. What root do we have for sure?
Negative 3.
-3. Can we factor this? Let's see. Why? We need to multiply to make 9 and add to make negative 3. That doesn't do a thing. So what could I do instead? Oh my gosh, I know, I'm horribly cruel. X equals negative b, so 3 plus or minus the square root, b squared. 9 minus 4 times a times c. 4 times 1 times 9. Are we going to get a real root? No, we're not. Do we need to have a full explanation of what our imaginary root is? We're sketching. We don't need to have a full thing of the imaginary root. Our only real root is the negative 3. That was not the laser pointer. Our only real root is the negative 3. This is going to be imaginary. So we only have one real root. So when we're doing our sketch, all I have is my negative 3. And we know that our left arrow points up and our right arrow points down. I do have one more piece of information we can grab. Where is our y-intercept going to be? Negative 3. So I know that. That helped me a little bit. We're making a sketch, not a proper graph, so we don't have enough information to do like full-on plots. You could always make a t-table and get more information, but for the most part, it's a cube. I know it's going to be a cube, so I'm going to connect up my arrows, and I'm going to make it vaguely cube-shaped and call it good. I mean, don't put it as a line. There is one more kind of question I want to go through, and it's, I promise, not long, but it's one for some reason we get real stuck on. Okay? So one more question for today. And it's this one. So we got f of x is 3x cubed minus kx squared plus x minus 5k. And we're asked to find k, so solve for k is our job. Find k, that's our job. We want to find k. So that it has this point, negative 1, 4, as a valid point on this graph. What's your instinct? Don't say cry. Substitute. I have an x, I have a y. Substitute them in. My y is 4, and it's going to equal 3 times my negative 1 cubed minus k times my negative 1 squared plus my negative 1 minus 5k. So we have our 4 equals. We can solve this. 3 times negative 1 cubed is negative 3 minus k times negative 1 squared, which is just k, is minus k. So negative 1 squared is going to be positive. So we still have that 1 minus sign out front. Plus negative 1 gives us minus 1 minus 5k. What next? Combine some like terms. I've got negative 3, negative 1. That gives me negative 4. I've got minus k minus 5k giving me minus 6k. Add 4 to both sides. I get 8 equals negative 6k. So what does k equal? Ooh. Yeah. Negative 4/3. Okay, that's your answer. I don't know why, but we get hung up on that one. Okay. That's it.
Wait, where did we get the 4 on the far left side? Is that us filling in as again?
That was our y.
Oh, okay.
That was, I'm sorry, getting the highlighter. This y goes in place of y. That was this guy. Okay. So I'm putting this up here. For some reason it says 35. It should say 37, but if you do 35 instead, it's just harder. 37 is easier.
Did you guys draw a new problem or was that already there?
35 is harder than 37, so I switched it for 37. Biashki.
She switched 35 to 37. 35 is harder.
Mm-hmm.
Are you excited for your birthday tomorrow? Are you ready to be cold tomorrow?
If she can come to me, I'm planning. My goal is to be here all day. Yeah. Okay. Awesome. Thanks. Bye.